goes along with equilibrium. What does kinetic mean as opposed to static?
Moving.
Yeah. So the kinetic equilibrium means that the acceleration is zero, velocity is indeed constant, but the velocity is not zero. It is moving, it is sliding against the wall. So right off the bat, I know we are not dealing with the static. This is just there for fun. This is the number here that matters, that 0.3. All right, let's go through the exact same process we've gone through before. So let's sort of specify this means acceleration is zero. The change in the velocity is zero. And the total force is zero. And then kinetic just means it's sliding. Okay, fourth diagram.
Other force up and to the right.
The normal force to the left. And friction acting down.
And I know it's kinetic. So friction's done. We got the other, got the normal, got the gravitational tension.
No.
All right. It is moving upwards. Acceleration is zero. With acceleration being zero, we could pick any perpendicular coordinate system, any x, any way that we want to do it. It depends on how many things we want to break up. Personally, I would want to break up as few vectors as possible, which means, yep, going to Luis's hand gestures. So you did, I believe, that. And I'm going to make I hat the direction of movement and J hat that way. So what am I breaking up?
The other force.
All right. So when I break it up, it is conveniently listed so that, let's see, I got normal this way, I've got weight acting down, I got friction, kinetic friction acting down, and then I've got this force. The horizontal piece is going to be 100 times the cosine of theta, and the vertical piece 100 times the sine of theta. And if you don't see that immediately, we're breaking this up into, it's up and to the right. And this is my opposite side associated with sine. This is my adjacent side associated with cosine. Let's see, equation solution.
Y minus 100 cosine theta equals 0.
Okay. Equilibrium. Yeah, I've had students do the MA just out of habit and then get stymied because they forgot the equilibrium piece of it. All right, substitution. For what do we have an independent formula?
Weight and friction.
Yep. So I have y equals 100 cosine theta, and then I have 100 sine theta minus mg minus u k y equals 0. Y is an unknown. I can populate that. So let's take this, plug it in here. So I have 100 sine theta minus mg. Yeah, I gave you a mass. Minus uk times 100 cosine theta equals 0. So I have an equation with a sine and cosine in it. In theory, I've got one unknown, and that's theta, but it's not explicitly obvious how you solve for it. But what you need to do is isolate one of them. I'm going to isolate sine theta. So I have 100 sine theta equals mg plus uk 100 cosine theta. Now, I'm going to be writing a bunch of sines and cosines here. I'm just going to use a shorthand because I don't like writing that much. So I'm going to S equals sine theta. I'm going to let C equal cosine theta, just to limit the amount of writing. I am going to plug in numbers at this point, because otherwise I'm going to be dealing, I got 100 here, and I'm going to end up squaring some stuff here, so that'll give me 10,000, and I want to minimize the amount. So I'm going to divide everything by 100. So I have S is equal to mg, which is 4 times 10, or 40, over 100, plus uk, which is 0.3, times the cosine of theta. In other words, or times c. So this is 0.4 plus 0.3c. S equals. At this point, I'm going to exploit a major identity in trig, the fact that sine squared theta plus cosine squared theta equals 1. And so when I have a sine and a cosine like this, if I don't have a simpler way of getting rid of it, I'm going to have to square both sides. So questions before I go to the new page and square both sides. Kelly.
What is the 40 over 100? How did you get that?
That's I divided everything by 100. And mg divided by 100. The mg is the 40.
Oh.
And I divided that by 100, and then I divided this by 100.
Oh, okay.
Other questions? 0.4. So I have S is equal to 0.4 plus 0.3 C. And again, S is sine of theta, C is cosine of theta. Square both sides, I get sine squared is equal to 0.16 plus 0.24 C plus 0.09 C squared. I did that right, so 0.4 times 0.3 is 0.12 times 2, okay. For those who have forgotten, if I'm squaring a binomial, it's the first term squared, the last term squared, and in the middle, 2 times, just a times b. I still have cosine and sine, however, I got a sine squared here, and I know from the identity over there, this is 1 minus the cosine squared. Equals 0.16 plus 0.24c plus 0.09c squared. I now have a quadratic. So I'm going to get everything in terms of, well, I set it equal to 0. It's a quadratic equation. To use the formula, I need to get it into the ax squared plus bx plus c form. So I add c squared to both sides, so I have 1.09 c squared plus 0.24c, and then I subtract 1 from both sides, minus 0.84. And it's now plug and jug time into the quadratic formula. So my cosine of theta equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And someone's going to be kind enough to give me the two answers.
0.775, negative 0.995.
That is the cosine of theta, so the angle, which is what we're trying to find, is going to be the inverse function, or the arc cosine, of 0.775, or the arc cosine of negative 0.995. Wait, 7 degrees? 0.27 degrees. All right, so I have two answers here. Only one of them makes any physical sense. I have my angle defined from the horizontal. So the 39.19 degrees makes sense. It makes physical sense because I'm pushing against the wall. The other one, the 174 degree angle, well, if that's 0 degrees, and I'm defining it going this way, 174 is pointing on it in that direction. Which does not make sense, because if I'm pulling on the box, there's no way that it's pressed up against the wall. So physics kicks back in, and that's the answer. Now there are situations in which you get two correct answers. In this case, there's only one. More fun with friction. Right. Yay is right. Questions on this glorious problem?
How did you get the 1.09 squared and the negative 1.84?
Oh, how to get this?
Yes.
All right, are you good with this equation here?
Yes.
All right, so then I add c squared to both sides. So that's where I got my 1.09 c squared.
Okay.
And then I subtracted 1 from both sides. And so that's what gets me the negative 0.84. Other questions?
Are you gonna ask that?
Well, now that you've seen it, we'll talk about it. Again, just step by step. Okay, the tough part, I guess, was solving this part.
Because I wouldn't know to do the 1 minus c squared and all that stuff.
My recollection is when I did this for the 151 students thing before, they didn't know either. You know, if I ask a problem that everybody misses, it's probably a bad problem. All right. Why don't we connect the friction stuff, because it's so much fun, with the energy stuff that we had just done. Unless somebody else had another question before we blend some stuff. All right. Let's go ahead and